Good afternoon, everybody. I'm your host, David Celestin, and this is Biochemical Feud, the game show all about biochemistry. Today's topic is mainly focused on gluconeogenesis. There will be 4 rounds in this game show. Now, without further ado, let's introduce our lovely contestants. Over here on Team A, we have Samantha, Rudra, and Reina. On Team B, we have Kristen, Ezra, and Dana. Now let's continue on to the first round. The first round will be the speed round, where I ask the contestants a barrage of questions in which they will give me a simple answer to each one. Whoever hits the buzzer first will answer the question. This round will last 2 minutes, and the team that scores the most points in this time frame will be the winner of this round. So let's begin. When does gluconeogenesis occur?
Fasting 5 to 1 points.
Correct. Team A. Most important regulatory enzyme in gluconeogenesis.
Fructose 1,6-bisphosphate.
Correct again. Example of a hormone that stimulates gluconeogenesis.
Glucagon.
Correct, Team B. Where does gluconeogenesis mainly occur in the body?
Liver.
Correct again. Can gluconeogenesis and glycolysis occur at the same time?
No.
Correct again. Can glycogen degradation and gluconeogenesis occur at the same time?
Yes.
Correct, Team A. What is the effect of acetyl coenzyme A on pyruvate dehydrogenase?
Inhibited.
Correct again. What happens to malate in the mitochondria?
It's converted to acetoacetate.
Correct. What is one of the 2 places where PP carboxykinase is found in humans?
Mitochondria.
Correct, Team B. Are the carbons from acetyl coenzyme A used in gluconeogenesis?
No.
Correct, Team A. Is glucose mainly absorbed by passive diffusion or active transport?
Active transport.
Correct. Does insulin promote glycolysis or gluconeogenesis?
Glycolysis.
Correct. Is it lactase or lactate dehydrogenase is deficient in lactose intolerance?
Lactase.
Correct. Is it glucokinase or hexokinase that can regulate the blood glucose levels?
Glucokinase.
Correct again, Team B. Is it glucose 6-phosphatase or glucose 6-phosphate dehydrogenase that is deficient in von Gehrig's disease?
Glucose 6-phosphatase.
Correct, Team A. Is sorbitol produced by the oxidation or reduction of glucose?
Reduction.
Correct. Is free glucose or glucose 1-phosphate the end product of debranching enzyme catalyzed breakdown of glycogen?
Free glucose.
That's correct. Is trans-ketolase or transaminase that is TPP dependent?
Trans-ketolase.
Correct again. Is it 36 ATP or 38 ATP molecules that are produced in the complete oxidation of 1 molecule of glucose under aerobic conditions?
38 ATP.
Correct, Team B. The enzymes of the TCA cycle present in the mitochondria or the cytoplasm?
Mitochondria.
Correct, Team B. Now that's the end of the first round. It seems that Team A is leading by 10 points, while Team B is behind. Okay, now on to the second round. This round will be Pictionary. Whoever buzzes in first will be the team that participates in this round. That team will designate 1 member to be the artist. That member will come to me to receive the reaction pathway that they must draw. Their teammates must guess the pathway and complete it within the time frame of 2 minutes. This round is worth 100 points. Now round 2 begins now. B, you buzz first, you'll be able to participate in this round. Now, you must choose a designated member to come to me to receive the pathway. Okay, here we have Kristen. Okay, your time starts now.
TC. Oh, the corn recycle. Cow. Lactose. I mean, lactase. Well, lactase to pyruvate. Glucose. Oh, from glycogen. Glucose. Yeah, glycogen.
Okay, you now have 1 minute left.
Glucose. Glucose to pyruvate to lactate. 2 ATP, 2 GTP, and 4 ATP. This is in the blood.
30 seconds, Team B.
And the liver and the muscle. Right. Is that it? Yes.
Is that your final answer?
It is.
Congratulations, Team B. You have been awarded 100 points for winning round 2. Congratulations. Okay, now let's start the third round. In this round, it will be similar to round 1, in which each team will need to buzz to answer the questions. However, unlike round 1, these questions require much more detail. Question 1 is worth 50 points, question 2 is worth 100 points, and question 3 is worth 50 points. I shall begin round 3 now. In which steps of gluconeogenesis is NAD plus needed?
Lactate dehydrogenase form lactate from pyruvate. Malate dehydrogenase in the cytosol to provide oxaloacetate for cytosolic PP carboxykinase. And glycerol 3-phosphate dehydrogenase to form dihydroxyacetone phosphate.
Correct, Team B. You have been awarded 50 points for this question. Now to the second question. Glycogenic precursors. What substrates are used in gluconeogenesis in the absence of glucose?
Lactate from red blood. No. Lactate from glycolysis of red blood cells and muscles. The reaction is lactate plus NAD plus going to pyruvate and NADH plus H plus. The enzyme used is lactate dehydrogenase.
Glycerol from degradation of fats and adipose. The equation is glycerol with the glycerol 3-phosphate. The enzyme is glycerol kinase. The phosphate is coming from ATP. The glycerol 3-phosphate then goes to the hydroxyacetate phosphate. The enzyme there is glycerol phosphate with the cofactor being NAD+.
Glycogenic amino acids give rise to pyruvate or converted to the TCA intermediate which generates oxaloacetate. There are 18 amino acids that are glycogenic and only leucine and lysine are solely ketogenic.
Good job, Team A. You've been awarded 100 points. On to the next question. State any 2 of the main enzymes that are used and not used in gluconeogenesis. Team B.
2 that would be used would be adolase and enolase, and the 2 that would not be used in gluconeogenesis is PSK1 and hexokinase. They won't be used because they're irreversible reactions, so they are high energy barrier to reverse them. So the cell uses enzymes that have a low energy to activate them.
I think that is correct. You've been awarded 50 points. And that concludes the end of round 3. It's the fourth round and things are getting pretty heated. This is the case study round where I'll give a case study question to each team in which they have a limited amount of time to discuss the answer amongst themselves. When that time is up, the team will be given points for the correct answer as well as a valid explanation. If they give me the answer but not a proper explanation, they will not receive the total points for this round. However, the opposing team will be given a chance to include any information the previous team has left out. This round is with 100 points. Let's begin. A patient was eating poorly. He collapsed with seizures of fruity scent on his breath. His glucose levels were less than 45 milligrams per deciliter, and he was administered with intravenous glucose. His liver was also enlarged. Tests showed that his 3-hydroxybutyrate acetoacetate levels was increased. His lactate and pyruvate ratio was also increased, as well as his aniline levels. On further analysis, large quantities of bicarbonates were found in the liver. Bicarbonates inhibit the ATP-dependent carboxylation of biotin. What is the significance of the symptoms? And what is the enzyme being inhibited?
Blood glucose level is less than 45 milligrams per deciliter. That means the blood glucose level is below the acceptable levels for fasting, which is 70 to 100 milligrams per deciliter. The next point is he collapsed with seizures, revived with intravenous glucose. The brain relies solely on glucose as a primary source of fuel.
The third point is bicarbonates inhibit ATP-dependent carboxylation of biotin. Pyruvate carboxylase will be inhibited as biotin as a cofactor and mechanism of reaction with addition of carbon dioxide to pyruvate, which involves the initial carboxylation of biotin to the transfer of carbon dioxide, forming oxaloacetate. Oxaloacetate from the TCA cycle would be used as a glycogenic precursor of gluconeogenesis. Therefore, the reaction will be continued. However, it has a limited store. Histidine would stop the TCA cycle.
And lastly, due to the high lactate and pyruvate ratio, lactate is the glucogenic precursor. However, the reaction stops at pyruvate carboxylase. There will be a buildup of lactate.
Okay, thank you. Is that your final conclusion?
Our final conclusion is gluconeogenesis is inhibited because of the fact that pyruvate carboxylase is inhibited, and it is the first enzyme of the first bypass reaction of gluconeogenesis.
Alright. Does Team B have anything that they would like to add?
Acetyl-CoA is used to combine with an intermediate in the TCA cycle.
And acetyl-coenzyme binds with oxalates to form citric, but since you have no oxalate, that can't occur. So
There's an accumulation of acetyl-CoA, and the body needs to rid itself of the coenzyme A. So it undergoes ketogenesis, which produces 3-hydroxybutyrate, acetoacetate, and acetone. And the acetone cannot be further utilized by the body, so it's excreted through the individual's breath, which causes his fruity breath. And the ratio of 3-hydroxybutyrate to acetoacetate is increased because acetoacetate to 3-hydroxybutyrate is a spontaneous reaction, and acetoacetate to acetone is catalyzed by
because the 3-hydroxybutyrate is formed from acetate, which is an enzyme catalyzed reaction, so that could only occur in the cell. But the acetoacetate would be broken down spontaneously to form acetone in the blood when it's being transported from the liver to whatever tissues that needed.
And spontaneous reactions are favored, so you have more acetone than hydroxybutyrate.
So therefore you would have more 3-hydroxybutyrate than acetoacetate.
Yeah.
Okay, thank you, Team B. You've earned yourself 10 bonus points. Team A, you've earned yourselves 100 points. for answering the case study question. Wow, so it seems the teams are tied. That means we have to go to a bonus round to get a final winner. Now in this bonus round, each team must choose a representative. When a member is chosen, I'll give the question. The team to answer the question correctly in the time given will be the winner. Here's the question. State the thermodynamic applications of gluconeogenesis.
Gluconeogenesis has a high energy barrier compared to glycolysis. Gluconeogenesis is energetically costly, as it requires 4 ATP and 2 GTP to convert 2 molecules of pyruvate to 1 molecule of glucose. To maintain blood glucose, thousands of these molecules will be utilized. Therefore, thousands of triphosphates would be needed. The fuel is provided by beta oxidation, and for every 2 carbon removed from the fatty acid, 1 FADH2 plus 1 NADH plus BH plus is produced. These enter oxidative phosphorylation in the mitochondria to produce 4 ATP plural, thus 1 molecule of polymorate. A 16-carbon chain would produce 106 ATP after 2 ATP was subtracted from the fatty acid.
Is that your final answer?
Thus, 1 molecule of polymorate and 16 carbon would produce 106 ATP after 2 ATP was subtracted for fatty acid activation.
Looks like we have a winner. Congratulations, team A. You're our winner this evening. You're our winner this evening, and you have won the grand prize.
What's the grand prize?
That's all we have for today, everybody. Join us again next time on Biochemical Feud. My name is David Celestin. Thank you very much.